here I have some samples. I have a sample of aspirin tablets, paracetamol tablets, this Anodin Extra with aspirin, paracetamol and caffeine, and I ran the NMR of caffeine earlier because you can't really get pure caffeine tablets. Okay, so first of all, obviously we have a solid pill, but what we need is to have this dissolved in our Nmr Solvent in order to run an Nmr spectrum. So first of all, I'm just going to grind up, I'm showing this for aspirin, but it's the same for all three. And then I need to take just a tiny bit. So the rule of thumb is if you can see it, you can NMR it. So just a little end of a spatula can go into here. And then I need an Nmr Solvent. So in this case I have deuterated chloroform. So this is chloroform, which is usually CHCl3, but in this case that H has been replaced with a deuterium. So that's 1 proton, 1 neutron, heavy hydrogen. And this is used because we're doing proton NMR, so we want an Nmr solvent that has no protons. And what we're going to have, we're just going to add the pipette full, so about 0.5 to 1 milliliter. And then we give it a good swirl. And aspirin is very soluble in chloroform, so the fact we see a little bit of solid still in here suggests that maybe we have some binders and some additives in this pill, which is not surprising. So then I have this NMR tube and I just squirt it in. And we're looking for about, the rule of thumb again is about 3 fingers. Let's have a look. There we go, 3 fingers. I've done quite a lot of these, unsurprisingly. So now we've made up our Nmr solvent and it's time to go look at the Nmr instruments and think about running our Nmr spectrum. So here are 2 Nmr spectrometers. The way these work is essentially you have a superconducting magnet with a probe in that excites and spins and then measures, and that your NMR tube goes in. And these also have these robot arm autosamplers, which we'll see in action later. They're both pretty much brand new instruments, and they're both used heavily both in our undergraduate course and for postgraduate research. So before I put my sample in the instrument, there's one really important thing I have to do. These are really powerful magnets, so they can damage things like watches and credit cards. So I just need to empty my pockets, grab the NMR sample that we prepared earlier, and go over to the machine. So there's one more thing we need to do before we run our NMR spectrum. Is we need to get this spinner and this depth gauge. And what we do is we set this to a predetermined depth for this instrument, and this spinner is like a flotation device for the compressed air that lowers the tube into the probe. So we get it at the right height to measure and to not damage anything. So now all I need to do is put it in this sample changer. So this machine can run up to 24 samples in sequence, and this one over here up to 60. So that's really useful if you have a lot of samples you need to run all at once. So this sample changer and robot arm is all controlled by compressed air, which is really great for running a lot of samples at once. This is really brilliant, and it's an example of automation in chemistry, how it can really increase the throughput. So if you look, it's going over, and now the tube's going down into the probe within the superconducting magnet, which incidentally is cooled with liquid helium in order to make it superconducting. So you can see kind of how the amount of infrastructure you need to run these instruments, you really only get them in kind of major corporations like big pharma companies and in universities.